The tale of the James Webb Space Telescope's capture of the first true image of the interstellar body called 3I/Atlas is one of those extraordinary scientific moments when engineering genius, cosmic enigma, and philosophical awe converge. When NASA revealed that the world's most powerful telescope had expanded its mirrors 1,000,000 miles from Earth and produced this stunning photo, it was not only another milestone in observation astronomy. It was a giant leap into a new era, when humanity would now be able to observe an interstellar visitor not as a brief blur, but as a discernible body bearing the record of another star system. If this kind of story touches your heart, if you're someone who cares about truth, responsibility, and speaking up for the voiceless, please like this video, subscribe to our channel and share it with someone who should hear it. Let's get started. To comprehend why this is such an incredible feat, one must first understand what the James Webb Observatory was built to accomplish. As the replacement for the Hubble Space Telescope, Webb's mission was ambitious: to gaze back into time to the most ancient galaxies, to unravel the atmospheres of exoplanets, and to chart cosmic structures hidden to ground-based telescopes. But alongside those big assignments, Webb has now unveiled something quite intimate in a surprise: an unambiguous picture of an interstellar traveler drifting across our solar system. And with that, Webb has barely opened its eyes, and the universe already seems fresh, more mysterious, more lovely, and more accessible to us than humanity ever dared dream. The object of this photograph, 3I/Atlas, is just the third known interstellar object to have been discovered. Then came the long-simmering subject of much debate, the 1I/Oumuamua, a thin elongated object whose strange path and shape raised talk of its possibly even being man-made, followed by 2I/Borisov, a more traditional comet-like passerby. Both were transient, faint, and poor candidates for comprehensive investigation. Telescopes found it hard to record anything but fuzzy streaks before these objects vanished back into the depths of interstellar space. With Atlas, though, Webb flipped the script. The clear image it produced is not just an image, but a scientific surprise, stripping away layers of mystery to reveal to us what an interstellar object really looks like. The first thing that strikes the onlookers is how clear the image is. Faint streaks and uncertain profiles are now a thing of the past. Courtesy of Webb's infrared sensors and its location outside the Earth's atmosphere, free from any distortion, Atlas shines forth with amazing clarity. No longer a smear against the starfield, it is disclosed as a material body with texture, surface detail, and even an observable coma of gas particles escaping from it. The infrared powers of the telescope have revealed glints and contrasts that no earthly instruments could ever hope to attain. The discoveries start with the surface itself. Astronomers debated for decades about whether interstellar travelers would resemble the icy comets of our solar system or adopt the rocky, inert forms of asteroids. Webb's photograph of Atlas provides the answer in a subtle way: the body seems both. Bright shiny spots indicate volatile ices sublimating under the influence of the sun, and darker scars suggest old impacts and fractures gained over its ageless passage through deep space. This duality suggests a hybrid origin, half comet, half asteroid, may be formed in the outer reaches of a far-off star system before it was blasted out by gravitational forces. Its coma, a wispy ring of dust and gas around Atlas, adds to the mystery. Less spectacular than that of solar system comets, it is nevertheless an important presence. It is that despite crossing the frigid expanse of space between stars, Atlas has retained volatile molecules. Now, in the warm comfort of our sun, those molecules are venting, presenting astronomers with a fresh look at untrammeled interstellar material untouched for eons. In a way, Atlas is a time capsule of the cosmos, transporting raw survivals of its formation on an unimaginable journey, now revealed by Webb's tools. Just as revolutionary are the spectroscopic readings Webb took. By breaking down the light that is reflected and emitted by Atlas into spectral bands, astronomers are able to determine its chemical makeup. Already, preliminary analysis has uncovered water ice, but also oddball organic molecules not typically encountered in solar system comets. These substances may contain crucial information about the way chemistry plays out in extraterrestrial conditions. More significantly, they reinforce the hypothesis that interstellar objects could be messengers of cosmic chemistry, seeding the galaxy with life's building blocks. If prebiotic chemistry sparking molecules are common, then life could be a galactic process, not a cosmic accident on a single planet. Size contributes another dimension of intrigue. As opposed to Oumuamua's thin, oval shape or Borisov's comparably tiny nucleus, Atlas is several kilometers in diameter, closely resembling a proper comet nucleus. The reason why such a massive object survived its cataclysmic ejection in one piece points to extreme gravitational interactions in its parent system, perhaps with enormous planets or transient stars, that ejected it into interstellar banishment. Its survival past innumerable cosmic dangers bespeaks the tenacity of planet fragments and suggests that many more likely remain quietly drifting between stars, undetected. Webb's accurate monitoring of Atlas's path establishes beyond any doubt that it is interstellar. Its hyperbolic path demonstrates that it will only traverse our solar system once before moving off into space forever. In contrast to comets that are gravitationally attached to the Sun, Atlas is just passing through, a brief visitor whose tail we shall never get to see again. This lends poignancy to Webb's feat. Without its equipment, Atlas could have passed unremarkably as another entry in an astronomical ledger. Now, it's a richly documented case study of interstellar travelers, turning theory into empirical fact. Comparison with its predecessors shows glaring contrasts. Where Oumuamua's strange shape fueled speculations of artificial origin, Atlas appears more ordinary, albeit still unusual in nuance. Where Borisov was a typical comet, Atlas has a hybrid personality, part icy, part rocky, part comet, part asteroid. These distinctions emphasize the variety of interstellar visitors and, by implication, the range of planetary systems in the galaxy. Each object tells a different story of birth, disruption, and exile, offering us a rare chance to peer into the processes shaping distant worlds. The implications spread far wider than astronomy. The moral of planetary formation models is that they have us explain the survival of these giant interstellar bodies. Astrobiology is provided with new proof of the interstellar dispersal of the building blocks of life. Cosmochemistry is given access to an unaltered sample of extraterrestrial matter. Even philosophy is implicated, as human beings consider the sobering fact that matter from other stars is passing through us, visible in real time. Visually, the photo is nothing less than profound. To the general public, it is not just science, it is an eye into the intimate grandeur of the galaxy. To look at Atlas as it glows pale in the starfield is to understand that somewhere out there, another star cluster brought it forth. Somewhere, forces ripped it loose, propelling it on a journey that, by happenstance, crossed our solar system. Each of its scars, each of its patches of shining ice, is a page in a book written through millions of years of history. For scientists, the accomplishment is a vindication of decades of work. Webb was not only built to explore the distant universe, but also to unveil the buried details of close-by events. The image of Atlas elegantly combines these missions, a local observation with cosmic significance. Each pixel in the photograph is a victory of precision engineering, meticulous alignment, and immaculate implementation. It is a testament to what humankind can do when curiosity is joined with creativity. This information coming in from Webb is just the tip of the iceberg. Simulations of Atlas's thermal behavior, rotation, and erosion are already being tuned. Its chaotic tumbling tells of a violent history of collisions, and surface features expose a mottled mix of ices, minerals, and carbon-rich materials. Some of the unusual organics that have been found may be completely unknown to science, forcing chemists to rethink how complicated molecules form elsewhere in the universe. Its surface could even leave behind a record of galactic interactions, signs of supernova radiation, interstellar clouds, or star flybys inscribed into its chemistry over millions of years. The cultural significance of Webb's portrait cannot be exaggerated. In schools, it will motivate future generations of researchers. In museums, it will serve as a reminder of humankind's growing cosmic presence. In policymaking, it could stoke increased investment in space travel, as popular interest converts into support for bold missions. For artists and poets, Atlas is already a metaphor, a solitary immigrant from another star, undertaking a silent passage through eternity. Maybe the most thrilling prospect is what follows. As technology advances, the likelihood of catching such interstellar travelers with probes becomes more achievable. Consider a mission that might collect a sample from the surface of an object like Atlas directly, studying its chemistry in close proximity. Webb's photograph isn't just an ending but an incentive for such dreams, a glimpse of what can be achieved and a reminder of what will be lost. Ultimately, Webb's reveal of 3I/Atlas is not merely a scientific breakthrough. It is a deepened awareness that the galaxy is full of movement and interconnection. Interstellar space is not void but strung with wanderers, each of whom brings a tale from a foreign star system. For the first time, we are able to behold one of them clearly, in vivid detail, not theory but fact. This is what makes Webb's achievement revolutionary. It closes the distance between the unknown and the material, the ephemeral and the eternal. It shows us that our solar system is not a solitary island but part of a cosmic web where matter floats and intermingles across stars. And as human beings gaze upon the face of Atlas, it is not merely an interstellar thing we behold, it is a bridge, a reminder, and an invitation. An invitation to continue gazing outward, to continue wondering, and to continue dreaming what other tales the universe yet contains, yet for us to reveal.